Tonight, I want to take you on a journey, a story about the universe, told with real facts, yet in a calm, gentle way. Together, we'll travel from the first spark of the Big Bang, through the birth of stars and galaxies, and into the vast cosmic web that connects everything. Imagine drifting through space, surrounded by light and silence, as the universe slowly reveals its story. Let's explore the cosmos together, one gentle step at a time. Before we speak of stars or planets or even light, we must step into a place where there was nothing. Imagine closing your eyes in a silent room. No air, no sound, no warmth. Now take even that away. No time ticking, no space to move, not even a corner where nothing could sit. That is where our story begins. The beginning of the universe is not like the beginning of a sunrise or the opening of a book. It was not waiting behind a curtain, ready to appear. It was different. It was the birth of the curtain itself, the stage, the lights, and even the time on the clock. All at once. Scientists call this the Big Bang. The name can be misleading. It makes us think of an explosion, loud, fiery, violent. But it was not a bang in the way we know. There was no space for sound to travel, no air to carry it. Instead, you might imagine a balloon that was smaller than the tip of a needle, stretching suddenly, impossibly fast, filling with a presence that had never existed before. If you've ever lit a candle in the dark, you know how a single flame can chase away emptiness. The Big Bang was like that candle, but not in one room, not even across one sky. It was the first spark of everything, spilling into what would one day become galaxies, stars, planets, and eventually us. In that instant, less than the blink of an eye, time itself began. Before it, there was no before. You cannot ask what happened earlier, because earlier did not exist. It is like asking what lies north of the North Pole. There is simply no direction to point. Picture it this way. Imagine a blank page, without ink, without edges, without even the whiteness of the paper. Then suddenly, a single dot appears. From that dot, the page itself grows, stretches, and expands outward. That dot was not just on the page, it created the page. That is what the Big Bang was, the dot that painted the canvas of existence. In that very first flicker, the universe was unimaginably hot, far hotter than the center of any star you know. A heat so intense that the laws of physics we trust today, gravity, light, even time, were tangled together like threads in a knot. For a fraction of a second, everything was compressed into a single, dense seed. And then it began to stretch, not into empty space, but creating space as it went. Imagine bread dough rising in an oven. The dough does not grow into something, it creates the room for itself as it rises. Galaxies would later drift like raisins inside that dough, carried along by its swelling. In those first moments, the universe did not look like the sky we know today. There were no stars shining, no planets circling, only a sea of energy, shimmering like waves too bright for eyes to see. It was wild, restless, and yet beautiful in its own way. If you were standing there, though you could not have stood, for there was no ground, you might have felt it as a warmth, as a flood of light so pure and endless that it had no source. It was everything, everywhere, all at once. This is how our universe began, not with a bang you could hear, but with a silence so vast it carried the weight of all things yet to come. From this seed of nothing came everything, every mountain, every star, every breath you have ever taken. You are, in a very real sense, a story written in the ink of that first spark. And so, with that single act of creation, the great tale of the cosmos began. Slow, steady, and eternal. The universe was still in its infancy. A newborn with no stars, no planets, not even the faintest glow of starlight. It was smaller than a grain of sand, yet it carried within it everything that would ever exist. Scientists call this beginning the Planck Era, the very first instant after time began. It lasted for a fraction of a second, so brief that even the fastest blink would be too slow to notice it. And yet, in that sliver of a moment, the rules of everything we know, gravity, matter, light, were being written. Imagine pouring all the oceans of Earth into a single drop of water. Now imagine compressing all the mountains, all the skies, and all the galaxies into that same drop. The density of the young universe was even greater than that. It was a storm of raw energy, too intense for matter to exist as we know it. At first, there were no particles, no atoms, no protons, not even the smallest building blocks of matter. The universe was a furnace of pure energy, boiling and surging. But slowly, like steam cooling into droplets, energy began to transform into particles, tiny sparks that would later build the world. Think of it as the first grains of sand falling into an hourglass. They were small, fragile, and quick to vanish, but they marked the beginning of form in a formless sea. Quarks appeared, the smallest pieces of matter we know. They swirled in the heat, colliding, separating, joining again, like dancers learning the first steps of a cosmic waltz. Then came protons and neutrons, born from those quarks locking together. They were still far too hot, far too restless to form atoms. But they were the seeds, the first notes of a melody that had only just begun. During this time, the universe itself was changing. It was not a ball of fire expanding into empty darkness. Instead, space itself was stretching, carrying everything within it, like a wave spreading across a pond. Imagine an inflating balloon, its surface growing larger, each point moving farther away from the others. If you draw dots on the balloon, they drift apart, not because they are moving on their own, but because the balloon itself is expanding. That is what space was doing. The young cosmos glowed, but not with the calm light of stars. It was more like a blinding storm cloud, a haze so thick with energy that no light could escape. The universe was opaque, like milk swirling in water. If you could have looked at it, you would not have seen stars shining. You would have seen brightness everywhere, without shape or boundary. It was chaotic, yet within the chaos there was order quietly waiting to emerge. The laws of physics, gravity pulling, electromagnetism guiding, forces binding, were setting the stage for the universe to grow into something more. This was the first spark, the moment when existence stopped being a silent potential and became an active, living story. Out of heat came matter. Out of chaos came rules. Out of nothing came something. If you want to imagine it, picture the first firefly on a summer night. At first, the darkness is complete. Then, in a brief flicker, a tiny light appears. It does not yet light the field. It does not yet guide your steps. But it is proof that more will follow. The firefly is the promise of many more glimmers until the night sky becomes alive with sparks. So too was the first spark of the universe, a promise. Galaxies, stars, and planets were still billions of years away, but in these early moments the foundations were laid. The universe had opened its eyes. It was not yet the vast cosmos we know, but it was no longer nothing. It was something, burning, glowing, and alive. And in this humble beginning, hidden inside a storm of unimaginable heat, the future was waiting. Every tree, every ocean, every thought you've ever had was already encoded in that first spark, like a story waiting to be told. After the first spark, the universe was still tiny, smaller than a grain of sand, yet alive with possibilities. Energy and matter had begun their dance, but space itself was restless. It wanted to grow. And grow it did, faster than anything we could imagine. This was the era of cosmic inflation. Imagine stretching a rubber sheet so quickly that every dot on it moves away from every other dot, almost faster than your eyes can follow. Space did not just expand, it stretched and stretched, carrying energy and particles along with it. In the blink of an eye, the universe became many times larger than before, and in doing so, it began to create the stage for everything that would come. During this rapid expansion, the universe remained incredibly hot. Particles collided endlessly, forming tiny clumps of matter, separating and coming together again. These interactions were chaotic, yet quiet patterns were emerging, tiny differences in density that would one day become the scaffolding of galaxies. Imagine a calm pond into which you drop a pebble. The ripples spread outward, small yet powerful. In the young universe, these ripples were invisible to our eyes, but they guided the formation of stars and galaxies billions of years later. Even in the chaos of inflation, order was quietly taking root. As space stretched, light itself struggled to travel. Photons, the particles of light, bounced off the dense soup of energy and matter, unable to escape. The universe was a glowing fog, brilliant yet opaque, as though someone had filled a sky with mist that shimmered like fireflies in a jar. Gravity, subtle but persistent, began its work. It pulled slightly denser regions of matter together, tugging gently at the rest of the universe. Imagine a group of dancers holding hands loosely, swaying to a rhythm only they can hear. This invisible force would guide the formation of galaxies, stars, and planets in the eons to come. Even as the universe inflated, the tiniest seeds of future structure were planted. These fluctuations in density were like small seeds in a field. Alone, they seemed insignificant. Yet, given time, they would grow into mighty forests of galaxies, nebulae, and stars. The universe, though still young, was learning how to organize itself. Cosmic inflation was brief in the scale of time, lasting only a fraction of a second. But its impact was profound. It smoothed out the universe on large scales, stretched tiny wrinkles into vast structures, and ensured that the cosmos would evolve in a way capable of forming complexity. Imagine a painter rapidly flicking a brush across a blank canvas. In a single motion, the strokes seem chaotic, but step back and you see that they form the background for a masterpiece yet to come. So too did cosmic inflation lay a backdrop for the universe's future, a universe that would one day shine with galaxies and light. As the inflation slowed, the universe continued to expand, but now at a gentler pace. Particles cooled, energies balanced, and the first atomic nuclei began to form. The young universe had grown from a tiny dot into something vast, stretching across distances so enormous they defy imagination. It is difficult to picture, but imagine looking at a dark room suddenly filled with a fog of soft, glowing light. The fog moves, stretches, and swirls, yet within it, patterns start to emerge. That is what the universe looked like after inflation, still chaotic, still radiant, but now with the promise of form, structure, and light. And so the universe entered the next chapter of its story. Inflation had set the stage. The first particles had appeared. Gravity was beginning its silent choreography. And the cosmos, once tiny and dense, was now a vast expanse, full of possibility, quietly preparing for the birth of the first stars and the cosmic light that would one day shine across the heavens. After the universe had stretched and cooled slightly, the first real building blocks of matter began to appear. These were not stars or planets yet, but tiny invisible particles, quarks, protons, neutrons. You can think of them like the first grains of sand in a vast, empty desert. Alone, they seem small, almost insignificant. Yet together, they would one day form mountains, oceans, forests, and even you. Quarks were the earliest of these particles. They zipped and twirled through the young universe, never resting, colliding and recombining in a cosmic dance. You might imagine them as fireflies moving through a misty night, flashing briefly, weaving patterns that hint at a greater design. These quarks join together to form protons and neutrons, the sturdy cores of the atoms that would one day make up everything in the cosmos. But the universe was still a furious storm. Temperatures were so high that these particles could not settle. They crashed together and broke apart in an endless rhythm, as if the universe itself were rehearsing the dance of matter. It was during this time that the first atomic nuclei began to form. Hydrogen, helium, and traces of lithium came into existence. Imagine droplets forming in a boiling pot of water, tiny islands of stability appearing in a sea of turbulence. These elements were the raw ingredients for all stars, planets, and life. Even as particles formed, light struggled to move freely. Photons bounced endlessly off the dense soup of matter, unable to travel far. The universe remained opaque, like a foggy morning where the sun tries to pierce through. Yet within this fog, the first patterns of the cosmos were beginning to emerge. Slightly denser regions tugged on surrounding matter with the gentle pull of gravity, planting the seeds for future galaxies. Gravity was subtle, yet persistent. Imagine invisible threads connecting the particles, tugging lightly, guiding them into gentle formations. These invisible forces were the architects of the future universe, quietly shaping what would later become stars, planets, and galaxies. During these first moments, the universe was still tiny in the cosmic sense, but already it held all the potential for infinite growth. The tiny particles, though small and fragile, carried the blueprint of everything that was to come. Every galaxy, every star, every atom in your body had its origins in this chaotic, glowing dance. The universe was also still expanding, carrying the newly formed particles outward. Imagine a balloon dotted with tiny beads. As the balloon inflates, the beads move away from one another, yet each bead remains part of the same balloon. So it was with the early universe, particles drifting, colliding, and forming, all while the cosmos stretched silently around them. If you could observe this moment, you would see a glowing, writhing cloud of energy and matter, almost too bright to behold. Yet it was beautiful in its own way, a symphony of motion, light, and potential, a reminder that even the smallest beginnings can lead to magnificent creations. And so, the first particles laid the foundation for everything that would come next. They were the seeds, the notes in the first verse of a song that would last billions of years. Stars, galaxies, planets, and life itself all waited in these humble beginnings, hidden in the flickers and flashes of the cosmic dance. As we drift deeper into the story, imagine floating alongside these particles. Feel the rhythm of the universe, the pulse of creation. Know that this tiny, invisible dance is where all things truly begin. The universe was young, restless, and full of potential, preparing patiently for the first light to finally shine. By now, the universe had grown larger and slightly cooler, yet it remained an intense, glowing sea of energy. It was no longer a tiny dot, but still far from the starry sky we know today. Imagine a fire burning so fiercely that it lights an entire room without a flame you can touch. That is what the young universe looked like, radiant, turbulent, alive. Particles moved at incredible speeds, colliding again and again. Quarks, protons, and neutrons danced together in a rhythm too fast for human eyes to follow. Like sparks in a vast furnace, they zipped through space, sometimes joining to form tiny clumps, sometimes breaking apart. Chaos and order intertwined in a delicate, almost invisible waltz. The universe was hot, unimaginably hot. Imagine standing near a candle, then multiply that warmth by 1 billion. There was energy everywhere, pulsing, vibrating, and creating tiny ripples that would eventually shape galaxies. These early ripples were like tiny waves on a pond, almost too small to notice, but in time they would become the rivers and oceans of the cosmos. During this era, light could not travel freely. Photons bounced constantly off particles, trapped in the glowing soup. The universe was opaque, like fog so thick that even the brightest lantern cannot shine through. Yet within this fireball, the seeds of the first structures were quietly forming. Slight variations in density, barely perceptible, were pulling matter together, guided by the invisible hand of gravity. Gravity, gentle but relentless, shaped the chaos. Imagine threads stretching through a swirling storm, tugging particles toward each other, coaxing them into patterns. It was subtle, patient, invisible to the eye, yet it would sculpt everything to come, the first stars, the first galaxies, and eventually the worlds we walk upon. The universe was also expanding. Space itself stretched outward, carrying the fiery soup along. Imagine painting dots on a balloon. As the balloon grows, each dot drifts apart, yet remains connected by the surface. The universe moved this way, everything expanding, drifting, yet forming a cohesive whole. Even in this extreme heat and motion, the first nuclei of hydrogen, helium, and traces of lithium were forming. Like tiny seeds planted in a glowing garden, these nuclei were the first steps toward the stars. Though still fragile and isolated, they held the promise of complexity, the quiet blueprint for everything to come. It was a universe alive with potential, yet silent in ways we cannot hear. No sound, no voice, only the gentle rhythm of creation itself. Imagine standing in a vast sunlit field, feeling energy without seeing its source. That is what the cosmos felt like in these moments, a radiant, restless ocean, preparing to cool and organize. As we imagine drifting through this fireball, picture particles moving like fireflies in a dense fog, each one a tiny spark of possibility. Some will come together to form the first stars. Some will drift apart, waiting for their moment. All of them carry the promise of the universe's grand story. And so the fireball universe continued its journey. Hot, bright, and turbulent, it was still only beginning to tell the tale of light, matter, and the stars. It was the universe's first dance, a flickering, glowing symphony of creation, setting the stage for the first light to shine freely across the cosmos. As the universe expanded, it began to cool, not like the air outside on a chilly night, but in a way beyond imagination, so hot that even the hottest star today would feel like a gentle breeze compared to it. Yet this cooling brought the first glimmers of order, and the universe began to simplify. The first atomic nuclei had formed: hydrogen, helium, and traces of lithium. You can imagine them as tiny building blocks, like small Lego pieces scattered across a vast empty floor. Alone, they might seem insignificant. Yet these simple pieces held the potential to create the most intricate structures in the cosmos. Energy still roared through space, but matter was now beginning to settle. Imagine a pot of boiling water slowly cooling, the bubbles calming, the surface settling into a gentle ripple. The universe, once a furious fireball, was starting to find its rhythm. During this cooling, photons, the particles of light, were still trapped, unable to travel freely. The universe remained opaque, a thick, glowing fog, shimmering like morning mist catching the first sunlight. It was a beautiful, quiet kind of brilliance, not the sparkling stars we know, but a soft, pervasive glow that filled every corner of space. Gravity continued its patient work. Imagine invisible strings gently pulling the scattered Lego pieces together, coaxing them to form patterns. These early pulls were subtle, almost imperceptible, but they set the blueprint for galaxies, stars, and all cosmic structures yet to come. Tiny variations in density, like small hills and valleys in a vast field, guided matter into gentle clumps, waiting for the moment when light would finally shine. This era was called the recombination era because electrons began to combine with nuclei to form neutral atoms. The universe, once a restless soup of charged particles, was now starting to behave more calmly. Light, which had been trapped for so long, began to travel freely. Imagine opening a window in a foggy room. Sunlight spills in, soft but unmistakable. That first light was faint, almost shy, yet it marked a profound change. The cosmic microwave background, the echo of this first light, stretches across the universe even today. It is a whisper from the earliest times, a gentle reminder of the moment when chaos began to settle into order. Every photon traveling through space carries a memory of this era, a tiny messenger from the newborn universe. Even in its simplicity, the universe was alive. Clouds of hydrogen and helium drifted, colliding and coalescing slowly, forming the first gentle patterns of structure. Imagine soft clouds in a quiet sky, drifting with purpose, shaping the landscape in ways too subtle to notice at first glance. These clouds would one day gather into stars, then galaxies, painting the heavens with light. As the universe cooled, it was also becoming more hospitable to complexity. The frantic chaos of the first moments had passed, leaving behind a calmer, more ordered cosmos. Energy, matter, and space were learning their places, setting the stage for the first stars to ignite. And so, in the cooling and simplification of the cosmos, we see the quiet elegance of creation. The universe, once wild and blazing, was now settling into a gentle rhythm. It was preparing for the first light to shine, for the stars to awaken, and for the cosmos to begin its long, graceful story. A story that would one day include planets, life, and even us. At last, after millions of years, the universe was ready to let light travel freely. For the first time, photons, the tiny particles of light, could escape the dense fog of matter. Imagine a thick morning mist slowly lifting, revealing a quiet, glowing landscape. That was the moment of recombination when the universe first became transparent. Before this, light had been trapped, bouncing endlessly among electrons and atomic nuclei, unable to travel far. The cosmos was opaque, a glowing sea without clear shapes. But now, like a shy visitor stepping into a new room, light moved freely, carrying with it the memory of the universe's earliest moments. This first light is still with us today. Scientists call it the cosmic microwave background, a faint whispering glow that stretches across the sky like a soft blanket of history draped over the cosmos. Every photon is a messenger from the past, telling the story of the universe's first million years. Imagine walking through a quiet forest at dawn when the first rays of sunlight filter through the trees. Shadows and light play together gently, revealing shapes and patterns that were invisible before. That is what the first light of the universe did. It illuminated the cosmos for the first time, gently revealing the contours of what would become galaxies, stars, and planets. Even though the universe was now transparent, it was still young, still small in a cosmic sense. Clouds of hydrogen and helium drifted across space, guided by the subtle pull of gravity. These clouds, though calm and quiet, carried the potential for extraordinary structures. Tiny differences in density, small hills and valleys in the gas, would one day grow into stars, galaxies, and clusters. Gravity worked patiently, like an invisible gardener shaping a garden over centuries. It nudged matter together, coaxed clouds into gentle spirals, and prepared the stage for the first stars to ignite. These early patterns were subtle, almost invisible, but their influence would echo for billions of years. Imagine a candle in a dark room. At first, it is a small, flickering flame, casting gentle shadows. Yet it holds the power to light the entire space. The first light of the universe was like that candle, small, quiet, yet full of promise. It marked the beginning of cosmic illumination, the first hint that darkness would not last forever. As photons traveled across space, they carried with them information about the universe's shape, density, and composition. They painted a picture of the cosmos before stars, before galaxies, before planets. It was a universe in its purest, simplest form, a gentle, radiant glow stretching across empty space, yet full of possibility. This first light was not just a moment of brightness, it was a moment of revelation. The universe, once opaque and restless, had grown calm enough to let its story shine. The patterns imprinted in this light would guide the formation of everything to come. Imagine a painter laying down the first strokes of a masterpiece. Soft, careful, full of intention. That is how the cosmos began to reveal its beauty. And so, with the first light, the universe stepped into a new era. The fireball had cooled, the fog had lifted, and the stage was set for the first stars to awaken. We are still bathed in that gentle glow today, billions of years later, a reminder that even in the vastness of space, the quietest moments can hold the most profound beginnings. After the first light of the universe had begun to travel freely, a quiet and mysterious time followed. There were no stars yet, no glowing points in the sky, only vast stretches of darkness, deep and endless. This was the cosmic dark ages, a period when the universe rested in silence, waiting for its first lights to awaken. Imagine standing outside on the darkest night you've ever known. There is no moon, no distant city lights, only infinite blackness stretching in every direction. That is what the universe looked like. Yet within this darkness, incredible things were happening. It was a time of preparation, a calm before the first sparks of starlight. During this era, hydrogen and helium clouds drifted slowly through space. Gravity tugged gently at the denser regions, pulling particles together like invisible hands arranging pieces on a cosmic chessboard. The seeds of stars and galaxies were forming quietly, hidden within the shadows. Think of it like a winter forest before sunrise. Snow blankets the ground, trees stand in silence, and every movement is slow, deliberate. Beneath the quiet surface, life is preparing to awaken, though nothing seems to happen. So too did the universe prepare, setting the stage for the first bursts of light. The darkness was not empty. It was filled with potential, with energy and matter waiting patiently. Tiny variations in density, almost imperceptible, were the blueprints for the future. Imagine gentle ripples forming in a still pond, almost invisible, yet capable of shaping everything that follows. These small ripples would guide the formation of the first stars, the first galaxies, and eventually the cosmic web. Even though there was no visible light, gravity was at work. It pulled and nudged clouds of gas, shaping them into gentle clumps. These clumps were the quiet architects of the universe, invisible yet essential. Without this patience and subtle guidance, the universe would remain dark forever. During the Dark Ages, the universe expanded, stretching space and carrying matter outward. It was calm, vast, and empty, yet full of promise. Imagine a blank canvas waiting for the painter's first stroke. The potential was immense, and the story was ready to unfold. This era of darkness also reminds us of the beauty in waiting. Though nothing sparkled in the night sky, the universe was learning, growing, and preparing. Every atom, every particle, every ripple in the hydrogen clouds was part of the silent work of creation. And then, after millions of years, gravity's patient pulling would ignite the first stars. These stars would pierce the darkness, bringing light and warmth, painting the cosmos with color and brilliance. The long, silent wait of the universe was about to end, and a new chapter of light and creation would begin. So as we drift through this dark expanse, remember, even in the deepest silence, something extraordinary is being born. The darkness between the stars is not empty. It is filled with anticipation, with the quiet promise of illumination, the gentle heartbeat of the universe before its grand awakening. After the long, quiet darkness, the universe was ready for its first lights to shine. Gravity had gathered clouds of hydrogen and helium into dense pockets, patiently waiting for the right moment. And then, at last, the first stars ignited, massive, brilliant, and fleeting. Imagine the first candle in a vast shadowed room suddenly flickering to life. Its light spills softly, revealing shapes and contours that were invisible before. The first stars did the same for the universe. They were small points of blazing energy in the vast emptiness, yet their presence changed everything. These early stars, called Population 3 stars, were unlike any we see today. They were enormous, hundreds of times the mass of our sun, burning hot and fast. Imagine a bonfire in the night sky, bright enough to light distant forests. Their lives were short, but their brilliance marked the dawn of the cosmos. Within these stars, the first heavy elements were born. Hydrogen and helium, the simple building blocks of matter, fused under immense heat and pressure to form carbon, oxygen, and other essential elements. You can think of it like cooking a meal over a roaring fire, simple ingredients transformed into something new and nourishing. The first stars also began to influence their surroundings. Their light pushed against nearby clouds of gas, shaping them, stirring them, and preparing them for the next generation of stars. It was a gentle yet powerful dance, a balance of creation and destruction that would continue across the universe for billions of years. As the first stars burned, they lit up the darkness, creating what astronomers call the cosmic dawn. Imagine a sleepy town at sunrise, where the first street lamps flicker out as the sky slowly brightens. The universe, once silent and dark, now shimmered with tiny sparks, hinting at the grandeur to come. Even as these stars lived and died, their influence spread. When they exhausted their fuel, some exploded as supernovae, scattering their newly forged elements across space. Imagine a painter splattering colors onto a blank canvas, each explosion adding richness, depth, and possibility. These elements would one day form new stars, planets, and perhaps even life itself. The first stars also mark the beginning of galaxies. Clusters of stars gathered together, forming the earliest structures of cosmic order. Gravity continued its quiet work, weaving the threads of the cosmic web, connecting stars into patterns that would span millions of light years. If you could drift among these first stars, you would see a universe alive with fire and light, yet still gentle in its rhythm. Each star was a beacon, a storyteller, a first note in a symphony that would echo across space and time. And so, with the ignition of the first stars, the universe stepped into a new chapter. Light filled the darkness. Matter began to organize into structures. And the cosmos, once hidden in shadow, began to reveal its beauty, preparing for the birth of galaxies, planets, and the incredible complexity that would one day include us. After the first stars had ignited, the universe began to organize itself into larger, more intricate patterns. Gravity, patient and persistent, pulled stars together into clusters. Clouds of gas swirled around these clusters, forming shapes that would become the very first galaxies. Imagine watching leaves caught in a gentle whirlpool of a stream. Each leaf drifts on its own, yet together they form spirals and eddies, patterns both delicate and strong. So too did stars drift, guided by invisible threads of gravity, slowly assembling into the luminous cities we call galaxies. The first galaxies were small, fragile, and chaotic compared to the grand spirals we see today. But they were beautiful in their imperfection, each one a shining collection of stars, gas, and dust. Within them, new stars were born, lived, and died, enriching the cosmos with heavier elements. Each supernova added color and texture, scattering the seeds of future stars and planets. These galaxies were not isolated. Gravity stretched its invisible hand across the void, linking galaxies into clusters, which in turn formed superclusters. You might picture a network of lanterns on a dark night, each lantern connected by threads of light, forming patterns that stretch far beyond what the eye can see. This was the cosmic web, the large-scale structure of the universe, vast and intricate, connecting everything together. As galaxies grew, they became cradles for new stars. Gas clouds within them collapsed under gravity, forming stars in gentle waves. Imagine a calm garden where seeds sprout slowly, each plant unfolding in time, creating layers of beauty. Within these galactic gardens, the universe learned to balance chaos and order, light and darkness, birth and death. The first galaxies also began to spin. Some formed spirals like pinwheels in a breeze. Others became irregular shapes, messy, yet alive. Their motion was graceful, a cosmic dance choreographed by gravity, momentum, and the invisible forces shaping the universe. Imagine dancers spinning in a quiet hall, moving with purpose yet freedom, each step contributing to a greater harmony. Through all this, the universe was still expanding, carrying galaxies farther apart, yet binding them together with invisible threads. Like beads on a stretching string, they moved away from each other, yet their connections remained, a subtle reminder of the unseen forces that sculpt the cosmos. Galaxies became the homes of countless stars, each star a light in the darkness, each light a story in the vast tapestry of the universe. Within them, planets would later form, and perhaps life. Every element in those future worlds, carbon, oxygen, iron, was forged in the hearts of earlier stars, scattered across space, and gathered into new forms. And so the universe, once a tiny glowing fireball, had grown into a magnificent web of galaxies. Light now danced across vast distances, carrying with it the story of creation, the memory of the first spark, and the promise of everything yet to come. The birth of galaxies was the universe's way of learning to organize, to flourish, and to shine. In these early galaxies, we see the beginnings of cosmic beauty, the first grand structures in a universe that would one day hold billions of stars, planets, and perhaps observers like us. The cosmos had awakened, full of light, motion, and the quiet pulse of creation, preparing for the next chapters in its infinite story. Even as the first stars and galaxies lit the universe, much of what holds the cosmos together remained invisible. This is the realm of dark matter, the hidden scaffold upon which everything else depends. Though we cannot see it, it shapes the universe quietly, like the frame of a house before the walls are built. Imagine a vast garden where you can see the flowers, the trees, and the birds, but cannot see the soil or roots that nourish them. Dark matter is that invisible soil, the unseen structure that gives galaxies their form and keeps them from drifting apart. Without it, stars would scatter, galaxies would dissolve, and the universe would be far emptier than we know. Dark matter does not glow. It does not shine. It does not emit light. We only detect it through its subtle pull on visible matter. Like a gentle, invisible hand, it tugs on stars and galaxies, guiding them into spirals, clusters, and cosmic filaments. Imagine a puppeteer behind the curtain, moving his strings carefully, orchestrating a dance we can only see but not touch. Even more mysterious is dark energy, a force that pushes the universe outward, accelerating its expansion. While dark matter pulls things together, dark energy gently pushes them apart. Imagine a balloon inflating slowly, yet some invisible pressure is pushing from the inside, stretching the surface ever faster. Space itself expands, carrying galaxies along, widening the gaps between them. Together, dark matter and dark energy form a delicate balance. Gravity, ordinary matter, and energy are like dancers on a stage. Dark matter is the floor, invisible but solid. Dark energy is the rising wind, unseen yet shaping every movement. Without this hidden scaffold, the universe would not have grown into the beautiful, complex tapestry we see today. The cosmic web, the vast network of filaments connecting galaxies, owes its form to dark matter. Picture a spider's web glistening in the morning dew. The threads, invisible to the casual eye, give shape and purpose to the whole. Galaxies gather along these threads, clustering at intersections, forming superclusters that span millions of light years. Though we cannot touch dark matter or dark energy, we feel their effects everywhere. They are the quiet architects of the cosmos, shaping its fate from the shadows. Imagine wind sculpting sand dunes. You cannot see the wind, yet it carves every curve, every peak, every valley. So too does the invisible universe shape everything we see. Even today, scientists are still learning about this hidden scaffolding. They track galaxies, measure motions, and observe how light bends in the cosmos, trying to map what is unseen. It is a reminder that the universe is always greater than what meets the eye, filled with mysteries that inspire awe and curiosity. So, as we drift among stars and galaxies, remember the quiet forces that make them possible. Dark matter holds the stage. Dark energy stretches the scenery. Together, they provide the structure and rhythm for all cosmic stories, ensuring that the universe, vast and beautiful, continues its grand, unending dance. By now, the universe had grown vast, its galaxies forming patterns across unimaginable distances. Yet hidden within this expanse was a quiet, mysterious force: dark energy. Unlike gravity, which pulls, dark energy pushes. It stretches space itself, making the cosmos expand faster and faster. Imagine a balloon covered with tiny specks of glitter. As you blow air into it, the balloon grows and the specks drift apart. But now imagine some invisible wind inside the balloon, pushing even harder, speeding the separation. That invisible push is dark energy, acting gently but relentlessly across the entire universe. This force is everywhere, unseen yet powerful. It does not shine, it does not touch, but it shapes the ultimate fate of everything. Galaxies drift apart, the spaces between them widening with time. It is a calm, persistent stretching, a slow ballet on a stage so large that we can barely comprehend it. Even as dark energy stretches space, gravity continues its quiet work, holding galaxies and clusters together. The universe is a delicate balance, a cosmic tug-of-war between attraction and repulsion. Imagine a tree bending in the wind. The roots hold firmly, but the branches sway with the invisible currents. That is the dance of the cosmos. Dark energy also affects the life cycle of the universe. Stars form, galaxies evolve, and yet all of this occurs within an expanding space that grows with every moment. Distances we once thought small are stretched beyond imagination. The universe itself is growing, carrying everything within it like leaves floating on a river that never stops. Scientists only discovered dark energy recently, yet its presence has shaped the cosmos from the earliest times. It is a reminder that much of the universe is hidden, operating beyond our senses. Imagine walking in a forest and feeling the wind shaping trees even when you cannot see its source. That is how dark energy moves through the cosmos, silent, invisible, yet omnipresent. Despite its invisibility, dark energy is vital. Without it, the universe might collapse under gravity or evolve very differently. Its quiet push ensures that space continues to expand, that galaxies drift apart, and that the story of the cosmos unfolds over billions of years. Imagine looking at the night sky and seeing countless galaxies scattered across darkness. Each one moves, slowly drifting from its neighbors, carried by an unseen hand. This is the subtle effect of dark energy, a cosmic current stretching the very fabric of reality, shaping the stage for everything we observe. Even in its mystery, Dark energy invites wonder. It reminds us that the universe is more than stars, planets, or light. It is a living, breathing expanse, guided by forces both seen and unseen. The expansion continues quietly, gracefully, shaping the rhythm of cosmic time. And so, with dark energy at work, the universe grows larger with every heartbeat. Galaxies drift, stars shine, and the cosmic story continues. We are witnessing an ever-expanding stage, a vast theater where space itself participates in the grand, endless dance of creation. As the universe expanded under the influence of gravity and dark energy, a grand pattern emerged: the cosmic web. Invisible threads of dark matter stretched across space, connecting galaxies and clusters like the delicate filaments of a spider's web. Imagine looking at frost on a window, each tiny crystal linked to the next, forming a complex, shimmering network. Galaxies gathered along these invisible filaments, forming clusters and superclusters, creating islands of light in the vast, dark ocean of space. Some regions were dense, bustling with stars. Others were vast voids, stretching silently between the luminous strands. The universe had begun to organize itself on the grandest scale, revealing its majestic architecture. Picture a city seen from above at night. Streets and highways form lines of light, neighborhoods cluster together, and vast empty spaces separate them. The cosmic web is the universe's own city, built on invisible threads, glowing with the light of countless galaxies. Every intersection, every filament, tells a story of forces unseen but deeply felt. Within these structures, galaxies danced a slow, graceful ballet. Gravity guided them, dark energy stretched the spaces between, and the stars continued their eternal burn. Some galaxies collided and merged, forming larger galaxies, while others drifted apart, carried gently by the expanding fabric of space. Imagine leaves on a vast river, sometimes joining, sometimes drifting alone, yet always moving in harmony with the current. Superclusters, the largest structures in the cosmos, stretch across millions of light years. They are the cities of the universe where galaxies congregate, forming patterns that span unimaginable distances. Between them lie voids, quiet, empty regions like the silent spaces between notes in a song, giving rhythm and balance to the cosmic melody. The cosmic web reveals the beauty of the universe in its largest scale. It shows how tiny particles, formed in the first moments after the Big Bang, can come together under invisible forces to create vast structures. Imagine planting seeds in a garden. Over time, they grow into trees, bushes, and flowers, forming a living tapestry. The universe, too, grows from its smallest beginnings into a magnificent cosmic tapestry. Even as we gaze at this enormous web, we are reminded of our own place. Earth, our sun, the Milky Way, all lie within this intricate network connected to the vast structure of the universe. We are small, yet part of something much greater, a story written across billions of years and unimaginable distances. And so the cosmic web stands as a testament to the universe's hidden order. From the tiniest particle to the largest supercluster, everything is connected. Gravity, dark matter, dark energy, and the first light of the cosmos all come together in this delicate, beautiful structure, a web that binds the universe in a grand, silent dance of creation. As we drift through the vastness of space, we pause to reflect. From the fiery birth of the universe to the first stars and galaxies, every part of the cosmos is connected. Imagine standing on a quiet hill at night, looking up at countless candles in the darkness, each one holding a story older than time itself. We are small, yet part of this grand tapestry. The atoms in our bodies were forged in stars long ago. In every breath, every heartbeat, we carry the memory of the cosmos. Like tiny seeds with the potential to grow into mighty trees, we are children of the universe, connected to everything we see, and much that we cannot. Even in silence and darkness, there is meaning. The stars, galaxies, and cosmic web remind us that beauty and creation are woven into reality. Imagine drifting on a calm river, carried gently by forces larger than yourself, yet part of the flow. That is our place in the universe, small, fragile, yet precious, and intimately connected to the infinite. Sleep now with this knowledge. Let the calm rhythm of the cosmos fill your mind. The universe is vast, eternal, and wondrous, and within it we have a place, a quiet, beautiful, and unforgettable place.